Okay, guys, so
Like an aerosol gun, so it looks really cool.
I want to talk a little bit, before we get into the shortcut kind of rules, okay, I want to talk a little bit more quickly about differentiability and continuity. Okay, so it's kind of continuing what we talked about yesterday with the alternate definition of the derivative. Okay. And we're just going to basically, let's see here. Yeah. Jump into two kind of examples here. So remember we talked about what it means to be continuous already, right? That was in the limits section, right? So a function is continuous. Visually, we can kind of see that, right? If there's no holes, no asymptotes, no jumps, right? That kind of thing. By the definition of continuity, right? For the function, the limit must exist at a particular point. The function must exist at that point, and the limit and the function must have the same value, right? That's continuity. Limit must exist, function must exist, limit and function must be the same thing. For differentiability, the derivative must exist. You must be able to take the derivative at that point. Now, since the derivative, right, is basically a limit, that means then that limit must exist. So, like the left-hand, right-hand side must agree, and stuff like that. So, all right, what we're going to do here is we're going to sketch a graph of each function. We're going to do two. Okay, and we're going to determine the intervals in which the function is continuous and the intervals in which the function is differentiable. So again, sketch the graph of the function, determine the intervals in which it's continuous and the intervals in which it's differentiable. That's what happens when I talk and write. I miss words. All right, so sketch graph of each function, determine the intervals in which it's continuous and the intervals in which it is differentiable. All right, so the first one we're going to look at is f of x equals 1 over x. Okay, so let's sketch this graph here real quick. This is one we should be familiar with right off the bat. No need to even use our graphing calculators, right? It's going to look something like that. Okay, so we don't need calculus to discuss the continuity of this, right? So, let's see here, So, let's see, so Nate, how would you describe the continuity of this? For what intervals is this graph of 1 over x going to be continuous? Okay, beautiful. Negative infinity to 0, union 0 to infinity. Right? And how are we able to determine that 0 we have a problem? What was the issue with them? Exactly, and you also could determine it by the function itself, because what happens to the function when at 0? It's the value of the function approaches negative infinity or positive infinity, or we can also say it's just undefined too. Same thing. Yep, exactly right. Yep, very good. Okay, so that's continuity. But now we got to look at the differentiability, right? Where are we able to take the derivative? So maybe we should actually find the derivative then of this thing, right? Now, did we take the derivative of 1 over x yesterday? Oh, we did 2 over t yesterday. All right. Well, we'll do 1 over x then real quick. So we're going to do the limit as delta x, or real slow because these take forever. Let's see, limit as delta x approaches 0 of f of x plus delta x minus f of x all over delta x. So go ahead, I'll let you guys get another shot, right? You guys should be able to do that. What's that? Can we just learn the shortcut yet? No, not yet. This one, that would make it a lot quicker, but...
Carter's like, it's 4.
Okay, so just do that real quick, or quick as you can. Okay.
Oh God, I thought, for some reason when you were shaking that, I thought it was like a pill bottle, and I was just like, what is
Gotta take my pills.
What is he doing?
That's right. It's my antipsychotic meds, so I don't turn into a monster.
Well, maybe you should take this.
So I got the setup. I set it up for you there, the initial setup, so that can be half the battle.
All over. Yeah. Making this way too difficult.
Entire game issue.
Like, I just feel like it's way harder than it should be. Like, I feel like I'm doing it like...
We need to do a lot of work.
Okay. So there's what we should have gotten. Okay. Are we okay with that? Questions on any of that? That's our derivative of 1 over x.
Did you not get that right?
No, I got x on the denominator of the top equation before you
Right here, x times x plus delta x?
Yeah.
Okay?
I got
Don't
X.
distribute that.
Yeah, I didn't distribute it, but I still got x squared times x plus delta x squared. Oh, never mind.
Okay, you're
Wait,
okay?
Wait.
So when you do the subtraction here, Mac, x times 1 gives you the x plus delta x there, it's minus the quantity
Yeah.
x plus delta x.
Whoops.
Minus, it should be minus the quantity x plus delta x.
Mistake.
So the minus sign distributes to the x and to the delta x there. You see that? Yeah, well, it is x minus x, but it's also then minus delta x as well, because the minus is in front of parentheses. It should be. You see? Yes, there, exactly right. Yeah, it distributes. Yep, be careful with that. Okay, back on track here. So, now, there's our derivative. So will this function f, is this differentiable everywhere according to our derivative?
What?
Is f
No.
able to be differentiated at every x value?
No.
Here's our derivative. Do you see any problem x values for this derivative?
0.
0. Right. If we plug 0 into our derivative, we're going to get undefined, which means that f is not able to be differentiated at 0. So then what would be the intervals of differentiability for f?
Same as the ones for continuity.
The same for continuity. Negative infinity to 0, union 0 to infinity. Okay? So because our derivative has a problem at 0, okay, because our derivative has a problem at 0, that means our function is not differentiable. Our function is not able to be differentiated at 0. The value of the derivative at 0 does not exist, so the function is not differentiable at 0. Okay? That's kind of the idea there. All right? Questions on that? Anything unclear? So differentiability is kind of like looking at the continuity of the derivative. Okay? You can kind of think of it like that. Think about differentiability kind of like looking at the derivative and considering the continuity of the derivative. Okay? And then you say about the original function, wherever, for example, so again, the derivative has a problem at 0. Since the derivative, you can't find the value of the derivative at 0, that means the original function is not differentiable. You are not able to differentiate this thing at 0. Okay? It would give you undefined. Let's try another one. F of x equals the absolute value of x minus 2. Okay, we've already kind of talked about this. Right, we already saw an absolute value function.
Do we sketch it?
Yep, we're going to sketch it. So, absolute value of x minus 2, Brandon, how is this shift going to happen? 2 to the right, you got it!
This shift is going to happen.
That's right.
Shift is going to go down.
So,
Shift happens.
that's right. Shift happens, bring graph paper. Okay, so... Thanks.
I'm
I try.
I'm going to look that one up on YouTube after this class.
Play it for your friends. Okay, something like that. Okay. What's the slope, by the way, on either... So what's the slope of this side, for example? Negative 1. The slope of this one is positive 1, okay? The slope of these sides change if there's a coefficient, okay? The slopes change if it's coefficient, okay? But in this case, because it's just a 1 in front, and so we just have negative 1 and positive 1. Okay, great. Cool. All right, let's describe the continuity. Okay, so let's see here. So Josh, looking at the graph here and kind of what we know about continuity, are there any places where this graph looks like it's not continuous? Yeah, no, it's continuous everywhere. Negative infinity to infinity. Okay? Now, differentiable.
Ooh.
Okay? Now, how do we take the derivative of an absolute value function?
Uh-oh. It's nasty. You can't do it.
Calculus ends here.
Yeah.
Right.
You put your pen down, go home, and take a nap.
Do you do two different? Do you do it twice? Do you do it for positive values and for negative values?
So here's what we're going to kind of look at here, okay? Because absolute values are kind of like nice, all right, and I know you don't think that, but what I mean is like, the slope we said to the left of 2 is always going to be what?
1.
always going to be a -1 slope, right? And then to the right of 2, all of these slopes along here are going to be a slope of what? +1. So we can actually come up with a piecewise function here, where sometimes it's equal to -1 and sometimes it's equal to +1. For what x values is our derivative going to equal -1?
When x is less than 2.
For x values less than 2. And then what about when will our derivative be equal to +1? For what x values? For x greater than 2. What's that? Right.
Wouldn't there be everything you do?
Right, yeah.
Wouldn't there be something for an x value of 2?
So, right, so but at 2, what do we want to say is the value of the derivative?
Well, there is no derivative.
It's undefined.
The derivative does not exist, because the idea is, again, if we imagine like this, my pencil here being like, my tangent line, and let's say like where my fingers are kind of pinching, that's like the point. So all along this side, I've got a slope of -1, slope of -1, and then at 0, from the left I'm going to -1, and suddenly I have to jump to the right of 0 to have a slope of +1. So I jump from a slope of -1 to a slope of +1. So my derivative is going to look something like this, if I can kind of like graph just beneath it here. I know this is going to be like right in the way, but so at the x value of 2, if this is f prime, this is f here, I'm going to have a slope of -1. Okay, I'll put that like -1. And then my slope of +1, it jumps up to there. And there's a jump there, so it's discontinuous. So that means it's not differentiable from -2 infinity to 2, union 2 to infinity. Okay, we have a jump. Our slopes jump from -1 up to +1. Sudden jump. Okay, so not differentiable. Okay, notice visually, what do you see is happening at 2? Like visually, what do you kind of see on the graph? It's a sudden. I mean, like just like what is it's suddenly changing. That's right. But like what would you maybe like? How would you describe what's happening there? Yeah, it's like a point. Okay, we have a point. So when you see like pointy parts of your graph, not like nice smooth curves, but like pointy parts like that, then that typically indicates that there is a discontinuity there. Is that, or sorry, not differentiable there? Does that mean, that's a good calculus-y explanation? No, but that's at least a good like visual way to kind of pick it out.
If points then not differentiable.
So,
if points then can't be weird.
okay. All right. I realize there are more of these than I thought, so we may not get to our shortcuts today. That's okay, though. Okay. Let's look at another one here.
Jesse doesn't even know. That was like Jack. What? Jack is at
1 over... Oh, no, never mind.
We just take keeper to x instead.
Actually, you know what? I'm going to get into the shortcuts because that I think this will be easier. So we'll hold off. We'll hold off on that. We'll come back to these later after we learn some of these shortcuts.
From overhearing my friends talk,
I know the derivative of x is 1.
More like without.
Okay, so pause on that. Let's get into the shortcuts, which I know really what you all have been waiting for, especially my Steinfeld students, because you guys are probably like, can we please? All right, here we go. Well, we just call this basic differentiation rules. Okay, we'll come back to that whole continuity and differentiability thing there, but I just wanted to throw that at you because, well, we could discuss it. We'll do more, though, with that once we kind of get these basic derivatives rules down, because I think it'll be better that way. All right, so step 1, or rule 1, the constant rule. Okay. From the homework, if you remember, if you don't, then that's okay. From the homework, okay, we saw that if f of x is equal to 7, right, this is one that Emma asked about, if you guys remember. Okay, if f of x equals 7, then what do we find that f prime of x was equal to?
0.
0. Okay. Right, and so that is then, so the constant rule then, and so 7, right, that's what we mean by a constant. If our function's constant, I mean, if our function is just a number, okay, the constant rule is that if a constant if a constant function is differentiable, then I can zoom in on this some, sorry. Okay. The derivative with respect to x of c equals 0. C is a real number. So the derivative of a constant is 0, which should make sense, because if our function is equal to a number, how does that look visually? Like, so f of x equal to 7, what does that look like visually, Ryan?
Straight line.
A straight, what kind of line?
A horizontal.
Horizontal line, okay, and a horizontal line, what's the slope of any horizontal line? 0. So the derivative of a horizontal line should be 0, because it's flat, okay? Okay. Now we're going to look at the power rule. But before we do that, I'm going to have you guys do some derivatives. Okay? So, the left side of the room, your left, my right, but your left, okay? This section, I want you guys to find the derivative of f of x equals x cubed. Oh, I'm sorry about that. You'll have to expand out a cubic, but yep, we're going to do it. Okay? Middle crew, I want you to find the derivative of g of x equal to x squared. And then,
Thanks, Miles.
this side of the room,
You can't do it.
No, she just said it was 2x.
I want you to find the derivative of x to the 1/2. Shh, Maya.
I mean, I could. So, based off of my,
No,
I think I know the answer.
So, but okay, but please just do the work. Shh, just do the work, okay? So please don't. You know, I want everyone to get a chance to see it though. So if you think you know it, great. But I want other people to get a chance to see it too. So there it is. So you guys are going to do x to the 1/2. You guys in the middle, x squared. You guys to the right, or sorry, on my left, on the left, x cubed. Okay. I'm going to do these, hopefully pretty quickly here. Okay. So let's see if I can do this.
Plus 2x alpha minus x squared divided group setting.
Because we can.
She's right, you know.
Well, actually, you guys are doing more work than they had to do. But
Yeah, you guys are doing amazing.
Thanks, Mr. Wood.
you're welcome.
We never learned really how to,
What?
yeah.
I doubt that.
She never taught us like to do all that.
No, I believe it.
Well, you did it probably like a little bit at first, but.
No, we just went right into the power
We just went right
rule.
into the power.
Oh, huh. Interesting.
La plus que tu sais, the more you know. No. What?
Oh my god.
And then banana is un banana.
Oh my god.
I said un banana. And then a melon is the banana.
Yeah, I was looking at it.
I was like,
how
where?
did you do that?
I was like, I'm looking, I was like, there's nothing you can do from here.
There's a French word in the 40s it's called the cocktail. Not even kidding. L-E space C-O-Q space. Really cool. It's pretty gruesome. How are you gonna say it like that? Their logo is a rooster with a triangle.
Oh my gosh, like, it was
You guys remember Nick called 19? Yeah. There's no wings. Yeah, I remember I was like 5 years old and my parents were on the play and yeah, I was very jealous. You're going to I'm better than found it.
I mean, didn't start playing with
I've been playing with Source since
Source?
Yeah.
Like CS Source?
Yeah. I've been playing with old? Yeah. I've been playing Source for like my whole life. My Steam account was 2000. I think, or 2003. One or the other.
Okay, we done? You don't have to do all three.
Oh, cute.
Sorry,
I was
Emma.
only halfway.
If you want to write the answers. Okay, so x cubed, when we take its derivative, becomes 3x squared. X squared, when we take its derivative, becomes 2x to the 1. X to the 1 half becomes, when we take its derivative, and rework it a little bit. Oh yeah, sorry, I see what you're saying. You're out of bounds there. Okay, there we go.
1/2 x to the negative 1/2.
I see a pattern.
Okay. Sorry?
Would you ever want that more simplified?
Yeah,
Like,
like
1 over x and 1/2.
yeah.
like this right here?
No, because you have a negative exponent.
Right.
Well, yeah, that's the same thing. So like, yeah.
Yeah, I mean, I accept
Would you
either of these.
accept the x to the 1/2 instead of root x?
Yeah, that's fine. Yep, that's
So,
okay.
x to the 4th would be 4x to the...
So, yeah, do we see the pattern here? X cubed, what's happening? Where does this 3 go? It goes out front, and then what happens to the original power? Subtract 1. So, old power goes out front, old power subtracts by 1 to get to new power. Okay, let's see if it works for x squared. Okay, what happens to the 2? 2 goes out front, lower the power by 1, 2x to the 1. Does it even work for fractions? Yes. X to the 1/2, 1/2 goes out front, lower the power by 1. Yeah, we have to do some fraction arithmetic here. 1/2 minus 1 is negative 1/2. There's the derivative. That's the power rule. Okay? Yep. Isn't that crazy? So, the power rule. Is if n, I'm going to use like a cursive n, if n is a rational number, then the function f of x equal to x to the n is differentiable. Bless you. and the derivative with respect to x of x to the n is equal to n times x to the n minus 1. What's that? No, I'm just using like a cursive n. Yeah, just cursive. Why? I don't know. I could have just used regular n, I guess.
Not y, n.
Well, that's what I did in my notes here.
Y.
Now, let me be very careful here to point something out that some students kind of or maybe you don't realize. This does not mean we can take the derivative of anything now. For example, what's the derivative of sine? No idea, right? We can't take the derivative of like trigonometric functions yet. Okay. What's the derivative of? Yeah, right. Well, okay. Some of us can't take it. All right. What's the derivative of like 2x plus 1 squared? Okay. I'll tell you this. It is not 2 times 2x plus 1 to the 1. Okay. The only thing that we know how to take the derivative of is a variable raised to a power. So that's it. Okay, so let's see some of these. Let's do some of these then, okay? So, all right? Shh. And remember, this is x. Shh. X is a variable. We are taking the derivative with respect to x. Okay, so this is very important here, okay? The derivative with respect to x of x to the n is n times x to the n minus 1. Okay, that's the derivative. So let's do some examples. All right, let's have some fun here now, okay? Now that we don't have to use our limits.
Because I wasn't having fun.
Yeah.
Some more fun. Some more fun.
So much fun.
Some people, Christian, were probably not having fun up to that point. But now they're so excited. All right, find the derivative. Here, ready? All right, let's do the first one. G of x equals cube root of x. Yeah, you're doing okay with this? You're welcome. So, cube root. We don't have a derivative rule for cube root. But how can we rewrite cube root of x? Rewrite it as x to the 1/3, exactly right. Now that it's x to the 1/3, then g prime of x, we can now use that power rule because it's x to a power. Okay, so what's going to come out front? 1/3 x to the negative 2/3. 1/3 minus 1 is negative 2/3. Okay, we're going to get very comfortable with fractions here, people, because it's going to require it in the calculus. Okay, so 1/3 take away 1 is negative 2/3. Okay, now we can rewrite that as 1/3 x to the positive 2/3. Or we can rewrite that as 1/3. How would I rewrite that using powers and roots? So yeah, cube root of x squared, or you could say cube root of x quantity squared. Either way. So either this is acceptable, I think most people said this, or you could also say this. It actually means the same thing. Those two things mean the same thing. Okay? So there you go. Yes, this is the correct answer, and you may stop here. However, I would recommend that you get comfortable with rewriting things in terms of both positive exponents and roots. So while I will not require you to do this, I will tell you this. If you have a multiple choice question, there is a very low chance that you're going to have negative exponents as a multiple choice answer. It will instead be rewritten with positive exponents, potentially even rewritten with roots. Okay? So please, while I told Jack that he didn't have to, and I think Brittany too, you guys both asked me this question, do we need to change the negative powers? No. But for multiple choice, you need to be able to match your answer. So I would recommend you practice doing it. All right, next one. Y equals 1/x squared. Okay, so let's see here. Y prime then would have to be 1/2x to the 1, right?
That was a trick answer.
That is not the answer. Why? Because it does not match our power rule as is currently written. does the power rule apply for 1 over x to the n? No, it's only for x to the n. So this way that this thing is written, we cannot take the derivative that way. We must rewrite this so it fits the power rule. How can we rewrite 1 over x squared so that it fits the power rule? Not x to the 1/2, that's square root of x. X to the negative 2. Okay, x to the negative 2. Now that it's x to the negative 2, we can now correctly identify the derivative. So what do we do with this negative 2 power? Multiply it out front, so it's negative 2 x to the... Very good. We are subtracting 1, so negative 2 minus 1 is to the negative third. And so we can rewrite that then using positive exponents as negative 2 over x to the positive 3. Okay?
Cool.
So please be careful. I'm trying to warn you guys ahead of time, right? It's like, oh, everything's so easy now. Yes and no. We do have a faster way to do these derivatives, but you have to make sure that it lines up with our derivative rule, our power rule here. Okay? It has to line up. All right? And then one more here I'm going to throw at you. Let's see here. And I'm going to give this one for you guys to try. So try this one on your own. Okay? Please do not shout out the answer so that other people can get a chance to think about it. I was not like trying to, hint at mine or anything like that. But please do not shout out the answer. Please find f prime of x here. Please do not shout out the answer. Okay? If you think you know it, please don't shout it out. Give other people a chance to try. Okay? What is the derivative of pi squared? Okay, I'll give you 2 seconds. That's all I really need, I guess. But okay. What is the derivative of pi squared? Ten more seconds.
Nothing will understand that one yesterday. That was so good. Everybody could do this.
Okay, so the answer is 2 pi to the 1, right?
Yeah.
No.
That's what I did, so.
It's not 2 pi to the 1.
Oh, please kill.
Okay, I put this one up here on purpose. I expected people to get 2 pi to the 1. That's why I said that. What is the derivative here?
Tricked again.
0.
Heck,
Wait a minute. Whoa, Mr. Whitmire. We just went through a power rule problem right here. X to the 1/3. You told me to bring the power out front and then subtract 1 to the power. We just did it here for B. And we had to rewrite it. Okay, we had to rewrite it. But x to the negative 2, bring the power out front, lower the power by 1, and it becomes.
I know
that,
why.
Okay. What's the problem here?
Because that is just a straight line.
Well, okay, yeah, that's basically, I want to hear constant. It's a constant. Pi
That's
squared
what I'm
is a
saying.
constant. It's just a number.
Boy.
It's just a number.
Ryan.
Oh, it's tricky though, right? Because pi, it's like a symbol that we use for a number, so it kind of like makes you feel like an x, but it's not an x.
It's
not
like
an
nine.
It's a number. What's that? No, if it was like 2 squared, if the derivative of 2 squared is 0.
If h is a rational.
Oh, if n's a rational number, that means the power.
I remember it.
Yeah, sorry, it's supposed to be n. Okay, so we're very clear on that. I did that on purpose because I want you guys to really be thinking here. We need to make sure when we take the derivative that it matches what the power rule requires. The power rule requires that it is x, a variable, to a number, okay, a fraction, or whatever you guys have there, okay? So x to the n becomes n times x to the n minus 1, okay? Pi squared is just a number, okay? So if I ask you what's the derivative of e squared, you're going to tell me what? 0, okay? Because e is, just a number as well. And it's gonna, cool. Okay. All right, so I think we should have enough time. I'm going to have you do one more thing here. So, find the equation of the line tangent to f of x equals x squared at x equals negative 2. Okay? Find the equation of the line tangent to f of x equals x squared at x equals negative 2. Do you want to do this on your own, or do you want to do it together? Together? All right, together it is. Okay, so what are we being asked to do? Find the equation of the line tangent to f. So to write the equation of a line, what two pieces of information do we need? Point and a slope. Okay, do we have either of those two things? Okay, let's go for the slope first. How do we find the slope of a tangent line? What do we look for? Look at the derivative. So we have to take the derivative of what here, Connor? Take the derivative of the function f, which is x squared. So f prime of x is going to be what? 2x to the 1, or just 2x if you want to leave it that way. Yep. Okay? All right, great. We've got the derivative. So is this the slope of my line then? How do I find the slope of my line? Put in the x value, right? We want to find the equation of the line tangent to this at this x value. So this x value will give us our slope if we plug it in. So we'll find f prime of negative 2. So it's 2 times negative 2, which is negative 4. So there's our slope. There's our slope. Okay? All right, so we've got a slope, but now what? We still need to find a point. I have an x-coordinate for my point, but how can I find the y-coordinate for that x-coordinate?
Plug it back in up top.
Plug it back into what?
X squared.
The original function, right? My line, our line, is going to be tangent to f at x equals negative 2. That means that my line will have the x-coordinate negative 2, right, and a certain y-coordinate, but it's also going to go through my equation. It's going to touch my graph here at the x-coordinate negative 2. And so they're going to share that single point in common. So I plug negative 2 in here. So f of negative 2 is negative 2 squared, which is 4. And so I have the point negative 2 comma 4. And so then that's my coordinate, right, or a point. And now, thanks to point-slope form, I'm done. Y minus 4 equals negative 4 times x plus 2. No need to find a y-intercept or anything like that. We're done. Wow, that's a lot faster and a lot less paper required for this problem than it used to be, right? That's right. Saving trees. Okay. So I'm going to give you a few problems for homework, but not a lot. Not a lot. I'm just going to give you a few. I don't know where that book is. 5 more minutes. You good, Connor? No, I'm pretty sure. Where do you get that from? I have not part. I took it off.
Or
Here, let me see here. Actually, you know what? No homework, but please do finish the assignment from last night if you did not finish it, okay?
I will
Change mine. And then, Ryan, you still need a book, though.
Do you have like a sheet where we wrote down all our numbers?